for Module 13.3, Special Right Triangles. Now, what do we know about the side lengths and the trigonometric ratios in special right triangles? Well, first, what are special right triangles? And our answer, real quick, is basically you have two triangles that are considered special right triangles. All right, they have 45, 45, and 90-degree angles, or 30 degrees, 60 degrees, and 90 degrees for their angles. So those are the two types of special right triangles. We call them 45, 45, 90, or the 30, 60, 90s. Okay, and those are considered special right triangles. So if you look at these lovely images here, those are actually um, the lengths, the side lengths of those special right triangles. Now, what's interesting is, let's say, for example, if you get a 45, 45, 90, okay, and they say this side is a length of 1, okay, so let's say this guy has a length of 1. That means, so again, if x equaled 1, then basically this side will also be 1, okay, so those two sides are the same length. And the hypotenuse is really just going to be 1 times the square root of 2. Now, if x was, let's say, 3, that means this side would be a length of 3, and this side would be the same, also a length of 3. And the hypotenuse would be 3 times the square root of 2. You guys see it in the notice of the pattern? All right, that pattern always exists with 45, 45, 90 degree special right triangles. Now let's look at the 30, 60, 90. It also has constant ratios on each of the side lengths. So let's say, for example, x equaled 1 for this 30, 60, 90. That means this side down here will have a length of 1, and this side right here would have a length of 1 times the square root of 3, or just square root of 3. And then this hypotenuse would have a length of 2, because 1 times, or 2 times 1, right? Now, let's say they gave us a different value. Let's say they told us x here equaled, I don't know, 3. All right, so if x equaled 3, sorry, that's a terrible 3, then this side would be 3 square root of 2, and this side would be, the hypotenuse would be just, well, 2 times 3, which is 6. So always use these ratios. That's for the hypotenuse. Okay, this is for the smaller line or line segment, and this is for the ratio for the second longest, the middle line segment. You know, he's like the second, he's like the guy in the middle. All right, so those ratios are what you have to remember for 30, 60, 90, while these are the ratios for the side lengths that you have to remember for the 45, 45, 90. So remember those, and you'll be okay. All right, so example 1, find the unknown side lengths of triangle PQR. Okay, so let's go ahead and see what kind of triangle do we have. It's a 45, 45, 90. How do I know? 45, 45, 90. Okay, that's how we know right away. So our ratios, again, if you remember them, QR has to be X, PR has to be the same. So by that logic, QR should also be the same as PR. So it'll be 2 square root of 6. Okay. And then the hypotenuse, remember, is x times the square root of 2, always, for 45, 45, 90. Well, x was actually given to us, right? They gave us one of the side lengths. So we're going to plug it in. 2 square root of 6, right, times that square root of 2. And when you multiply these together, you get 2 square root of 12. We can actually reduce, right, because the 3 and the 4, and the 4 is composed as a, a perfect square number. So when you square root 4, out comes a 2, right? And if you factor even more, you can do the whole, like, this guy can rat out because he's rational. and this guy gets, he dies in prison. So all you have left is 2 square root of 3. So that 2 is going to go out, and he's going to multiply with this 2 that's already out here waiting, right? So you'll get 2 times 2, that's 4, and that 3 can't be rational. There's no other pairs of 3s to get out, so he's just trapped there. And my pen is really giving me a hard time right now. There we go. All right, so those are the missing side lengths of that 45, 45, 90. And again, I just used the ratios for the lengths. All right, there's a ratio for the hypotenuse. This side has to be the same as this side. So again, I just use those 3 things to really just do the rest of the math. All right, your turn number 1. So again, what kind of triangle do we have here? And then find the missing pieces. Now, they did give you the hypotenuse straight up. So go ahead. We have to find the value of x. Well, the hypotenuse is what ratio? Oops. Again, it looks like it's going to be one of those videos where the pen gives me a hard time. All right, so that's the ratio. Solve for x, and then just plug it in. Find your missing side lengths. All right, 30, 60, 90. So here's example 2. Again, we're dealing with 30, 60, 90 special right triangles. Okay, and basically they're saying, well, the shorter leg, all right, happens to be 5 square root of 3. That's great because I know my ratios. I know that the small guy is basically just whatever they give you, x, or, it's just whatever that is, just x. The second smallest is x times the square root of 3, and then the hypotenuse has to be twice as much as whatever x is. All right, good to know. Okay, so again, have to know those ratios off the top of your head, and then we could use that to solve. So let's go ahead and plug in. That is x. All right, that's what's nice about them giving us the small little leg, is that the answer is just right there. Okay, for plugging it in. So that means we have 2 times 5 square root of 3, which is really just, well, 2 times 5, and that's 10. And then you have the square root of 3 on for the ride. Sorry, that's a terrible 3, I know. There you go. So there's DE, the hypotenuse. Then we're going to do the same thing with DF. So again, 5 square root of 3, and that's going to be times the square root of 3. And what's kind of nice here is, what's the square root of 3 times the square root of 3? That's like squaring. So your answer is just going to be 5 times that 3, right? Which is just 15. So DF will give you 15. Sweet. So it looks like we found our missing pieces. And again, I just used my ratios, which I knew the hypotenuse had to be 2 times the length of whatever the small guy was, which they gave us. Nice. And then the second to medium is always going to be x times the square root of 3. So again, memorize those. All right, your turn number 2. Again, what kind of triangle is this? Find the unknown sides. And again, it looks like they start off by giving you just the hypotenuse. Okay, so what are the ratios supposed to be, right, for the hypotenuse? That's my hint. That's all I'm giving to you. And then you use the rest of the ratios that I already expressed. All right. All right, now moving on to trigonometric ratios of special right triangles. This is the beginning of Algebra 2, the concept of the perfect circle, or the unit circle. Sorry, thinking about the band. But again, the unit circle is something that everybody beyond calculus has just ingrained in their brain. So this is where you guys just start to see it. Because, yeah, we do build circles using triangles. It's pretty crazy. So let's go ahead and focus here. Went off on a tangent. Get it? Tangent. Multiple dual meaning. All right. So sine of 45 degrees. Sine is opposite over our hypotenuse. Let's say our reference angle is the 45-degree angle. Does it really matter? No, it doesn't, because they're both 45s. All right. So, and they have the same ratios. All right. So here we go. Sine of 45 degrees. Opposite would be 1. Hypotenuse, square root of 2, right? And the hypotenuse, again, is always on the opposite side of the right uh, angle. Okay, so again, that's our hypotenuse, and this is our opposite. All right, let's do cosine of 45 degrees. So again, I'll use the same reference. Doesn't really matter which 45 I use. It's kind of nice about these kind of special right triangles. Adjacent, okay, which again is always the next door neighbor, who's not happens to be the hypotenuse. So that's 1. And then his hypotenuse is square root of 2. What do you guys notice about these two ratios? Right? It's crazy. All right. So they have that in common. All right. Now, tangent of 45 degrees. I'm going to use purple. All right. Again, still doesn't matter, but you know what? Just to kind of prove my point, I'm just going to use that one for 45. Doesn't matter. I could have used the other one. Opposite. Okay. So opposite. Okay, would be that guy, which is also 1. And then the adjacent is the next door neighbor, who doesn't happen to be the hypotenuse, which is also 1. Ah, interesting. All right. So, yeah, that's the beginning. All right. So again, we're still doing the whole opposite adjacent type deal based off a reference angle, but now you're just seeing it with special right triangles. And then the important thing to note here, especially for you who are going to take algebra 2, you will see that again for sure. Except it's going to be on a Cartesian plane on a graph with a circle on it. It's crazy. It's awesome. All right, here we go. Trigonometric ratios of special right triangles. So here's a 30-60. I think I already showed you the 45, 45, 90. But notice how there's a lot more going on, right? Because we have two different angles. The 45, 45s, well, that's just two 45s, so they're the same. Doesn't matter which 45 I use. On the other hand, with 30-60, yeah, there's a difference between which reference angle are you at. So I'll start off with the 30 degree. Okay, so here's our reference angle, 30 degrees, and again, opposite over hypotenuse. So that means the opposite is across way over here. Hypotenuse, again, is always going to be on the opposite side of the 90-degree angle. All right, and then just for kicks, pump up kicks, going round and round. All right, here we go. So sine of 30 degrees, opposite is 1, and the hypotenuse is 2. Okay. Cosine is adjacent over hypotenuse. That is square root of 3 over the hypotenuse, which is 2. Okay. And then tangent. Tangent of 30 degrees, opposite over adjacent, 1 over square root of 3. These ratios will always be the same, by the way. Doesn't matter how big this 30, 60, 90 will be. The sine of 30 is always going to be 1/2. Cosine of 30 is always going to be square root of 3 over 2. Tangent of 30 will always be 1 over square root of 3. Also, by the way, we do not leave the square root at the denominator. We're going to multiply this whole guy by 1. Get it? Because square root of 3 divided by square root of 3, that's just 1. But when we do this, when we multiply 1 times square root of 3 on the numerators will be square root of 3. And then square root of 3 times itself, just 3. So that would be your final answer if you got into that situation. And again, if you are going to algebra 2, you will definitely come to know these two numbers, these fractions in your head. They're in my head too. Okay. So it's just a normal thing you'll see in the future. All right, so sine of 60. Okay, so now our reference angle has changed. We are using 60, right? Now 60, all right, we just changed our position. So now this side would become the opposite. Oh, but hypotenuse is the hypotenuse, always the same. And then this side becomes the adjacent. So it does change depending on what your reference angle is, right? So opposite was again square root of 3. Hypotenuse 2. Okay, that's interesting. And cosine of 60, adjacent over hypotenuse. The adjacent was 1. The hypotenuse was 2. Okay. And then tangent of 60 was opposite over the adjacent, which is really just square root of 3. Now, reflective question. What do you guys notice from, oops, no, go back. There we go. All right, what do you guys notice with that guy to that guy? Okay, what do you guys notice? And then what do you notice about this guy to that guy and their ratios? So that's kind of like a reflective question. I kind of want you guys to think about that. All right. All right, your turn number 3. So trigonometric ratios for 45s. So we got a 45, 45, 90. Obviously, they did not give you, again, the values for A and C. You have to find those, and I'll give you a hint. Solve for x first. We already know that the hypotenuse has to be x times the square root of 2, but they gave us 10, so it has to equal 10. Solve for x. What did we get for x? Plug it in for here and here. And then again, find the unknown side lengths with the ratios, 40, 45 degree angles, and then work on finding sine of 45 degrees, cosine of 45 degrees. And this is what's so funny is if you're actually listening to me, instead of just writing this down, you would totally know your answers right away. It's pretty cool. All right, so there you go. Try it out and see if it is the same as what I already showed you, or maybe it's slightly different. Who knows? Who knows? All right, there is a pattern. There will be a pattern. All right, so your turn number 4, trigonometric ratios for 30 and 60. So find the unknown side lengths. So again, you have to know your ratios, right? That's my hint. Okay. And again, know what your hypotenuse is, and there's my other hint. Okay. So find DE and DF, and then for giggles, find the sine of 30 degrees, cosine of 30 degrees, tangent of 30 degrees, and then do the same thing except for the 60-degree angle. Sine, cosine, and tangent of 30 degrees. Now, I know you're probably like, Mr. Webb, why am I doing all this work? This is actually one of those videos that's like, okay, this is the beginning of the beginning, my friends. This is where we really start getting into more interesting math. So this is connected. Trust me. Wait next year, and you're gonna be like, oh dang, I remember that now. All right, so your homework, page 716 through 717, numbers 5 through 12, and let me know if you have any questions. Get it, because it's Thor's hammer. He can't get out, can't get his mask. Batman, because I'm Batman. All right, have a good day, guys.